Okay, this video is going to cover the first portion of our radicals notes for 8.0 preview into chapter 8. We are going to talk about just simplifying the radicals. First of all, this is, we'll go ahead and identify these different parts. First of all, what we know as the square root sign, we now need to know as the radical sign. We need to be able to identify that name as by say the radical, you know, drawing that square root sign. This little box outside is tiny one. It's called the index. In academic geometry at Katy High School, we will not be dealing with the index at all. Underneath the radical sign, we're going to have what's called the radicand. Hopefully I spelled that right. That's the number we're taking the square root of. Now we have numbers 1 through 25 squared. Okay, the numbers in the left column, them squared in the right. You're going to want to memorize as many of these as possible, both squaring the number and then also taking the square root back and forth. This is going to make our work a lot easier and a lot quicker as we go through when we have radicals as our answers. All right, simplifying radicals, just like with fractions. If you have 2/4, that is not simplified. You have to simplify it. A little bit easier to simplify those. Let's talk about how to simplify the radicals. There are two different ways I'm going to show you how to simplify these radicals. Okay, one is going to be by factoring using your prime numbers. What I like to, and then another one is try to identify your perfect squares. If you don't have your perfect squares memorized, you're going to want to do the factoring. I'm also going to show you two ways of factoring. Okay, one I like to call like the factor tree, or you guys learned that in algebra. Another one is what I call the division tower. So A, there's going to be a lot of work. B, I'm going to cut down where B through I, I'm just going to show you one way out of the three. Factoring. What this is we're going to go ahead and take square root of 63, and we're going to use our prime numbers. Okay, factoring is using your prime numbers. We need to remember, we need to memorize at least the first several prime numbers. Okay, things like 2, 3. Remember, prime can only be divided by 1 in itself. 2 is the only even prime number. Okay, we also have 5, 7, 11, 13, 17. We usually don't go above 17. Okay, so with factoring, we're going to want to see, okay, take our prime number. Can 2 go into 63? No. But we can do 3, and it'd be 3 times 21. 3 is a prime number, so we can't do anything about it. 21 can be broken down as 3 times 7. We're left with all prime numbers. We're ready to group and figure out what our final simplified answer is. My story is this is your radical house. Okay, you've got the inside and you've got the outside. What happens is outside of the radical house, we're having a three-legged race. In three-legged race, you have two people, a partnership, okay? And so all your pairs are going to pair up. Now, when you have two people, if you cross the finish line first, you don't get first and second place. You are one single being. So these threes are going to come together as a single 3 and go outside for the three-legged race. The little 7 who does not have a buddy, does not have a partner, can't participate. So the 7 is going to stay inside your radical house and play video games or do geometry homework. This is your simplified radical right here. Now, doing the perfect square, what we need to do is we need to be able to identify all of these perfect squares. And we're going to figure out which one can go into 63. And 9 is the perfect square that can go into 63. And this is a 9 times 7. Now that 9, because it's a perfect square, we take the square root of 9, it's 3 times 3. And so we have those exact same 3 prime numbers in the end. Again, here's our radical house. Outside, our partners will go. Inside are any numbers that cannot be paired up. On the next problem for the factoring using the prime numbers, I'm dropping off the perfect squares. Most students do not use that, but by all means, if you like that, please do use that. I'm going to show you what I call the division tower. Okay, we're going to start at the bottom and work our way up rather than the factoring right here. we're going to be working our way up. We're going to start off with the square root of 72. We are still going to use our prime numbers. We're going to look at what is the smallest. You do not have to start with the smallest prime number, but I highly suggest you start with the smallest because then your pairs will be grouped together. So start with the smallest. Can 2 go into 72? Yes, it can. When we divide 72 by 2, we get 36. We're going to keep dividing. Okay, I had the radical sign here, but now I'm just going to go ahead and do a division, do my division sign. Again, starting all the way back at the smallest prime number. Can 2 go into 36? Yes, it's going to go in there 18 times. Keep dividing by the smallest prime number until you cannot anymore. 2 can go in there again. That's going to give you 9. Now 2 cannot go in. Double check, 9 is not prime. So if 2 can't go in there, let's go up to the very next one. 3. Can 3? Yes. We're going to end with 3 at the top. Once you are at the very, very top of the tower, have a prime number, all your prime numbers, you're done. So just like with before, here is your radical house. Find your partners. Here I have a partnership of 2. It's going to go outside. The other 2 does not have a partner, so he's going to go inside. But then we're going to see another pair. So the 3 is going to go outside as well. The rule is everything on the outside multiplies, everything on the inside multiplies. So here 3 times 2 is going to give you 6, and there's nothing to multiply 2 with, so we just bring that down. Let's take a look at what happens if there is already a whole number outside the radical. What I'm going to do is down here, I'm going to go ahead and set up my radical house. What happens here is the 2 that is already there is going to stay there. Okay? And now we're going to go up and deal with our radicand and start dividing. Again, start with the smallest prime number. 2 goes in 4 times. Keep dividing until you have a prime number. It can be divided by 2 again, and you get 2. Now, grab our partners. Here's a partnership of 2. It's going to join the 2 that is already out there. Remember, everything on the outside gets multiplied. One last 2 left over that doesn't have a partner. We multiply the 2's on the outside. There's nothing to multiply on the inside, and there is your final answer. Okay, we have 6 more problems. We're going to see variations of different things happening here. Okay, first of all, I see that I have a whole number outside. So I'm going to go ahead and set up my radical house. The 6 we're going to go ahead and place outside, waiting to see how many other partnerships are going to come out to participate in the 3-legged race. And then we're going to take that 32. Again, prime numbers. Go ahead and write out those same ones, 2, 3, 5, 7, 11, 13, and I've rarely ever seen 17 in our work. But start with the smallest prime number possible. 2 can go into it 16 times. We can still divide by 2 to get 8. Still divide by 2 to get 4. Still divide by 2. We get 2. Prime number at the top of the tower. We're ready to grab our partnerships. Here's a partnership of 2, joining the 6. I have another partnership of 2, so we have an additional 2. And then that last 2 at the very, very top remains inside. We're going to multiply 2 times 6 to get 24. Square root of 2 is our final answer. Okay, taking a look at letter E, seeing a number outside the radical house. Go ahead and set up the house. 3 is going to wait outside. And let's take our 125. We are not able to divide by the smallest number 2. So we're going to move up to the next smallest number of 3. We cannot divide 125 by 3 either. So let's move to the next one. 5. 125 can be divided by 5. And we divide 125 by 5, we get 25. Okay? If you start with the smallest prime number at the very, very beginning, and you always stick with the smallest, now that we're going the second time, we don't have to start all the way back. Okay? We can stay with that 5. Divide by 5 again, and we get 5. Here we have a partnership of 5. It's going to join the 3. And then that last 5 doesn't have a buddy to do the three-legged race with, so he's going to go inside. We multiply the 5 times 3 to get 15. Square root of 5 as our final answer. Pause and rewind if you need to. I know I'm going fast through them. Letter F. Okay, I've got somebody outside, got the 4. Go ahead and bring him down to weight. And then we'll take our 216 and start dividing. Smallest prime number of 2, we can divide into. And we're going to wind up with 108. Keep dividing by 2 until you can't anymore. Here, we get 54. Divide by 2 again. We're going to end up with 27. We can no longer divide by 2, so let's check out. Can we divide by 3? Yes, we can. We divide by 3, we're going to get 9. We can still divide by 3, and we get 3. Prime number at the top of the tower. Let's grab all of our buddies. Up front. Here's a group of 2, join in the 4. All right, here's a single 2 that doesn't have a buddy. He's going to go inside. Here's a group of 3s to join the 2 and the 4. And then we have another 3 that's all by itself, so it's going to go inside. Rule is everything inside multiplies, everything outside multiplies. So 3 times 2 times 4 is going to give us 24. Square root of 2 times 3 is 6. Another thing is getting used to which numbers are already simplified. Like the square root of 6 is already simplified, so you know that if you have square root of 6, you don't have to go simplify that later. Okay. All right, next, let's see what happens with G. There are no numbers outside, so we're going to just jump straight to building our tower. Okay, I'm going to go ahead and put my radical house down here. Here we're going to take 196. Again, starting with the smallest prime number of 2. We're going to get 98. Keep dividing by 2 until we can't anymore. We divide 98 by 2, we're going to get 49. Now, 49 cannot be divided by 2. Next prime number, 49 cannot be divided by 3. 49 also cannot be divided by 5. This is why I suggest up to 17, because I don't want you to be like, okay, it's already simplified. Because if you jump up to 7, 49 can be divided by 7, and you're going to get 7. Prime number at the top. Let's grab the partners. Partnership of 2 outside the three-legged race. Another partnership here of 7 outside the three-legged race. Notice how there are no single numbers to go inside that radical house. So what that means is you're not going to have a radical sign in your answer. This is a perfect square. Your final answer is just 14. And we're going to go ahead and note here, perfect square. And if you look back at the previous page, we're going to see 196 was 14. All right, 2 more. Letter H, I'm seeing a number outside, so we're going to grab that 4, have them wait outside, and let's go ahead and take 10. When we divide it, smallest prime number, we get 2, and we divide, we get 5. We have a prime number at the top. What I want you to see here is what's underneath the radical. When you don't have any partnerships to throw outside, it is already simplified because you take all the singles here, 1, and the 5, you multiply them inside, you're going to get right back to 4 square root of 10. So this, we're going to note, already simplified. Okay? Sometimes you will have it where it's already simplified. All right, let's take a look at this last one. We don't have any numbers outside to come down here and wait for the race. So let's take 625. Smallest prime number 2 cannot go into it. Next smallest 3 cannot go into it. Next prime number 5 can. When we divide that, we get 125. Keep dividing. We can divide it by 5 again. we're going to wind up with 25. Divide by 5 again, we're going to get 5. Here are our partners. Pair of 5s waiting outside. Another pair of 5s waiting outside. We have no singles again, just like letter G, no singles. Multiply this out to get 25. When nothing is inside the house, this means we have a perfect square. And again, on the first page, we're going to see right here, 625 was a perfect square of 25. That back up in case you need to finish copying.